Well, hello. What I'd like to talk about in this video is one of the most important features of financial engineering, and that's sensitivity and break-even analysis. When you get out into industry, you're going to be dealing with a lot of very sharp people. And what's going to set you apart is your ability to present material. So most people are going to be able to do all the analytics. And what will set you apart in industry is your ability to anticipate things, to anticipate questions, and have answers to questions before they're asked. So when you do a presentation, when you're giving a presentation, you'll be able to answer a question that may not be expected. And the way you do this is with sensitivity analysis and break-even analysis. So what is sensitivity analysis? It's basically testing the sensitivity of your performance variable to an input variable. And so I'm going to show you a couple of examples of that in a little bit. But what I wanted to talk about is your performance variable. Your performance variable is going to be your after-tax present value, your after-tax internal rate of return, potentially your before-tax internal rate of return or present value. And then I'm going to talk about break-even analysis, and it's a form of sensitivity analysis changing one variable. And fundamentally, it's when two alternatives are economically equivalent. And I'm going to give you an example. It's when the project life it's one of the most uncertain values, and so that can be a point of break-even analysis. So let's look at this example. Let's consider a project that can be done in two forms. We can either build it with two-stage construction, spending $100,000 today and $120,000 N years from now, or we can build it with single-stage construction with $140,000 today. After 40 years, they're going to be have a zero value. And the question is, if the annual cost of O&M, operations and maintenance, is the same for both alternatives, what is the break-even value of N for these two projects to be equivalent? So this shows you, if you have the textbook, this shows you the one step, if you will, method of calculating the break-even point. But fundamentally, your present value of full capacity is $140,000 regardless of the age of when the second stage is constructed, or the timing of the second stage. The second stage, two-stage construction, if you do it immediately, the cost is $220,000. And the present value of this $120,000 is going to decline the further out into the future. And so the question is, at what point does it cross this $140,000 line? And that's when the present worth of the full stage construction equals the present worth of the two-stage construction. Now this shows you a one-step method using the n periods function. I don't typically like to use the n periods function. It's just not intuitive to me. Let me show you another method for doing this. So let's look at, this is our data here. We have an interest rate of 8%, and I'm going to arbitrarily set the period of n to 10 years from now. So we have the present worth of the full stage construction is $140,000. That's a given. This is the formula for the present worth of the two-stage construction, where we don't know the period n. So we use the 100,000 plus the PV function, and we need to calculate n. And we want these two values to be equal, or the difference between the two values to be 0. So let's look at the present value of the two-stage construction. That's going to equal $100,000 plus the present value of the rate is 8%. We're going to set the life to be 10 years, just as an arbitrary number, placeholder. We have 0 payments, and the future amount, we need to flip the signs, is minus $120,000. And so in 10 years, if our life was 10 years, we would be spending a present amount of $155,000 in two-stage construction. We want it to be $140,000, so we need to take this difference. We have a difference of $15,500, and we want this difference to be 0. So what we need to do is, I believe an easier way to think about this is using the goal seek function. And what we want to do is we want to do goal seeking. We want to set this value, the delta, to 0 by changing cell C4. That's the life. And we find out it's 14.27 years. And if we go back using this end periods function, 14.27 years. Now let's look at what we can do with another tool in Excel. And I'm not talking about this graphing tool, but I want to talk about setting up a table where we have the present worth as a function of the life. So let's go back into Excel. And let's say we want to have our life, let's just go zero, 5, 10, 15, 20, 25. So this is the number of years. And let's have our present worth. And this is what we want to have equal 140,000. So we need to refer to the calculated cell, 140,000. And now what we can do is we can use a data table. And so we're going to do highlight our data table, what if analysis, data table. Our column input cell is going to be, we don't have a row input cell. Our column input cell is going to be our life. And this is the variable that's referenced in this calculation right here. And so let's get this down to see what this looks like with the column. You can see that the 140,000 is right in here. So at a life of 0, it's the 220,000. A life of 5, the present worth of two-stage construction is 181,000. And we can graph this now. And then we would have our line of 140 would cross right through here. So I wanted to emphasize, when we're starting to do sensitivity analysis and break-even analysis, we want to start thinking about using data tables. Now I have in the Excel spreadsheet that I'm going to upload, I have an example of what if analysis when you change multiple variables. And so in the example, I show what can happen if you change your initial cost by 10%, your production per year by 20%, your unit revenue by 15%. And I guess there's not a real good answer as to what the best thing to do when you get into industry. You need to be able to read what your management likes to see. But again, one of the things that you might want to look at is where our performance variable is the present value, and in this particular example. And so I had the present value changing if we implemented an increase in our investment of 10%, and then our cash flow dropping by approximately, it's approximately 20%. It's the combination of the units per year and the net revenue. So that's one way to look at this. But again, our present value is our performance variable. So how can we analyze this doing with data tables? And let's look at what we could do here. We could say, let's say one of our variables is units per year. And so our units per year is, let's say, 1,000, 1,100, go all the way to 1,500. And our net revenue, let's make it go from, let's say, 15 we don't want this a percent, $20. We could go up to $35. Okay, now this is going to be a two-way data table. And we've got our units per year. Let's make this with. And what we need to do, and this has to be done, all these variables have to be in the same tab. And I'm going to demonstrate this in the Coastal project in just a second. So our performance variable is, let's say we want to look at the present value of the cash flow. So we set the performance variable there. And let's get rid of those. Let's make this in dollars. No decimals. Now a two-way variable table, what we want to do is remember this is set to the formula that we're measuring. We highlight the entire table. So our entire table is highlighted. We select data, what if analysis, data table. Now our row input cell is going to be the units per year, that's the $25. Our column input cell, I said units per year, it's net unit revenue, I'm sorry. The row input cell is the net unit revenue. The column input cell is the units per year. Now, this 79.29 is built on these two variables. So that's what's changing when we go into this data table. So now if we look at the results, at 1,225, we should get 79,000. 1,225, 79,000. What this table tells us is that if we look at the number of units per year, at 1,000 we have a present value of $54,000. Our value dropped by 25,000. If our unit revenue drops by 40%, our present value, even if we increase our units per year by, what is that, 25%, 300 over 1,200, we still can't get to the unit, the present value at a $25 net unit revenue. This data table formulation is super powerful. Okay, and you're going to want to use this to build your sensitivity. So what this tells you is, this is our base case right here, 1,200 units per year. This is the present value at various net unit revenue prices. So this is an input, this is a sensitivity input. These are our present values. And so at $25, this tells you the present value at different units per year. Super powerful.